Greetings everyone, we are from Group 11. Today we are going to present the optimal economic dispatch using the PowerWorld simulation. And me, myself, Alexander Anderson and Anthony, and my team member are Nick Marisa, Nick Maslan, Shoshana Ng, Ekpal, and Terence Low. And our lecturer is Dr. I.R. Said Nur Azizu.
So I'll be discussing the base circuit of the system for both transmission line 1 as well as transmission line 4. And as you can see for transmission line 1, for both cases for full load as well as half load, a majority of the cases should indicate that the circuit remain in overload or overflow when there is no generator or transmission lines have been added to the system. Now, this basically means the system has basically become exceeded its parameters or violated its parameters. Furthermore, one can also see that when there is no output from LSS1 as well as no output from LSS2, the incremental cost is the highest for both full load and half load. Now, this stands for 46.36 ringgit per megawatt hours for the full load situation, while 25.44 ringgit per megawatt hours for the half load situation. Interestingly enough, when there is only full output from the LSS1 only and no output from the LSS2, the incremental cost of the system is the lowest for both full load and half load, about 39.12 ringgit per megawatt hours for the full load, as well as an astounding 20.56 ringgit per megawatt hours for the half load. Furthermore, you can also see the varying output between LSS1 and LSS2 for both cases, about 50% for each, have at least the median range with regards to the incremental cost. Now, this situation carries on forward with regards to transmission line 4, the cases for transmission line 4. Now, as you can see for transmission line 4, with regards to the full load, there is again overloaded cases for both full load and half load. But interestingly enough, for transmission line 4, when there's half load with regards to no output from LSS1 and LSS2, there does not seem to be a significant overload as compared to the other systems. It still has an overload, however, it's not significant as compared to the other cases. Furthermore, as you can see, with regard to the incremental costs, the same situation basically plays out over here as well, with the highest incremental cost coming when there's no output from LSS1 and LSS2 for both full load and half load, saying about 46.34 ringgit per megawatt hours for the full load, as well as 25.44 ringgit per megawatt hours for the half load. This is because basically all the power generation is coming from the generators instead of the large scale solar farms. Thus, the cost of the system increases drastically. Now, as I stated before, the same situation applies with regards to the lowest incremental costs coming with when there's only full output from LSS1, with standing about 39.11 for full load as well as 20.56 for on the half load. And of course, with the highest incremental cost comes with the highest total hourly cost coming from both cases with regards to when there's only power generation coming from the generators instead of the solar farms. Now, the way to solve the situation will be addressed later on by my teammates with regards to adding generators and transmission line cables to basically ensure that the system is within parameters. The system doesn't become overloaded or overflowed, or the demand does not exceed the generation, nor does the generation exceed the demand, basically being in equilibrium instead of it being unstable.
Hello, good day. I am Shoshana, and today I'm going to present 5.2 approach 1 for variation circuit, and the method is by adding generator. I'll only be focusing on loss of transmission line 1, and I'll start with full load. So the parameters are, the loads are full load, and one generator is added at bus 5, and for the transmission line 1 here is being opened. So there are several cases. The first one is full load with no output from LSS1 and LSS2. The second case is full load with various output from LSS1 and LSS2, 40 megawatt over here and 75 megawatt over here. The third case is full load with full output from LSS1 only, which means the LS2 is not giving out any input, while for LSS1 it has 150 megawatt. And for the last case is full load with full output from LSS2 only, where LSS2 are having 80 megawatt output and the LSS1 has no output. Going on to the half load. So at half load, the difference between the half load and the full load is that the load are halved. However, the parameters are still the same. There is still one generator at bus 5 as it is the method, and they are using the same cases as in full load scenario, where the first case is with no output from LSS1 and LSS2. The second case is half load with various output from LSS1 and LSS2. The third case is half load with full output from LSS1 only. And lastly, half load with full output from LSS2 only. So we can see from all the simulation done, the generator and also the transmission line are all in range. Based on the simulations that have been done, the data is tabulated and the observation for loss of transmission line 1 is as shown here. So basically, if we were to compare between full load and half load scenario, and we use the first case, which is no output from LSS1 and LSS2, we can see that full load scenario is having a higher or more expensive total hourly cost and incremental cost. For example, here, the total hourly cost is 31,040 ringgit and 70 cents, while for half load is only 22,762 ringgit and 75 cents. The same thing goes to the incremental cost. Full load scenario is having much higher incremental cost than half load scenario. And we can see the same trend for all the cases here.
A very good morning. My name is Alexander Anderson, and I will discuss on the optimum dispatch for the losses of transmission line by adding generator. So mainly, we just add generator at bus here, which is bus number 5. We plan to add the generator at bus number 4, but what happened is it will increase the flow of current in the transmission line number 1. So what we do, we just move the generator from the bus number 4 to bus number 5. So the transmission line will be more stable. Okay, so we're moving on to the analysis. So for the full load, where there is no output on LSS1 and LSS2, as we can see, is the incremental cost will be the 28 ringgit and 1 cent RM per megawatt hour. And as we can see here, the full load varies output from LSS1 and LSS2. What we put is we put 40 megawatt hour for LSS2, and LSS1 is 75 megawatt. And then the incremental cost decreased to 24.27 ringgit per megawatt hour. And as you can see here, the full load with LSS1 only, which is on the full load 120 megawatt. The incremental cost will be 23 ringgit and 13 cent per megawatt hour. So it decreased even more as LSS1 would give more output to the system lah. As you can see here, the LSS2 it decreased to 80. We put LSS2 at 80 megawatt and LSS1 0 because it's full load from LSS2 only. And we do not include the generator at this side. However, when we do not put additional generator in bus number 4, it will overload the system, causing current to flow overload. So what we do is we add generator at bus number 4, and bus number 5. And the incremental cost is 14.99 ringgit per megawatt hour. So yeah, next one we go to the half load. Half load generally we just divide it by 2 all load attached to the bus bar. And then as we can see here, we use the same generator but attached to bus number 5. And then the incremental cost is 15.67 ringgit per megawatt hour, while the half load is 11 ringgit point 93 ringgit per megawatt hour. And for the half load is 10 ringgit 79 cent per megawatt hour. And for D, which is only LS2, is 13 ringgit point 07 ringgit per megawatt hour. So this is the observation that we obtain from the transmission losses of the L4. Observation for the transmission losses of as line 4, the L4. As we can see here, the highest will be there is no the full load will be no output from LSS1 and LS2. The incremental cost is the highest. We believe this because the LSS1 and LSS2 do not help in producing the power to the system. As we can see here, also the generator power is the highest. We can see it almost reach the maximum capacity. This shows that the dependency of the generator when there is no output from LSS1 and LSS2. And as we can see here, for the half load, the highest is the same, which is the no output from LSS1 and LSS2. And the lowest over here, which is the full output from LSS1 and LS2, and full output from LSS2 only. So that's all from me.
Based on the simulation and explanation done previously, we can come up with an analysis. For the first method, which is by adding a generator at bus 5, several values of generator are used to test for both the case at transmission line 1 and transmission line 4 respectively. Data obtained show that for both cases TL1 and TL2 yield the same incremental cost except for the case of full load with full output from LSS2 only. So as shown in figure 5.2, the incremental cost and total hourly cost is much higher than the cost in figure 5.27. This is because in 5.27, the number of generators that are used are 2, while in figure 5.2, we are only using 1 generator. So this shows that by adding more generators, we are able to lower down the incremental cost and total hourly cost of the system. And from the figures 5.17 till figure 5.31, it can be seen that adding generator to the power network with full load condition causes the circuit to not overflow. And from both table 5.3 and table 5.4, the overall price for the half load condition is much lower than the price for the case of full load condition. And the highest incremental cost is when there is no output from LSS2 and LSS1, while the lowest incremental cost is when there is full output from LSS1 and LSS2 for both cases.
Hello, now I will explain on the second approach for this violation circuit, which is we will add the transmission line to the network. I will explain on the solution based on the first aid consideration, which is loss of transmission line 1 only. Generally, with the loss of transmission line 1, we isolate the first, as you can see here. This part, there will be 2 types of condition, which is the first one is the full load and then the half load. For each, there will also be another 4 different conditions that varies on the LSS1 and LSS2. We will observe the power generated by each generator. That is generator 1, generator 2, generator 3, and this is LSS1, LSS2. When the transmission line 1 is isolated, it's actually the transmission line 2 and transmission line 3 will overload. Hence, the addition of 2 other transmission line is added in between bus 1 and bus 2, as well as bus 2 and bus 4, resulting to this. As a comparison between between 4 different conditions with full load. The first condition that is no output from LSS1 and LSS2, they produce the highest power, that is from generator 2, that is 461, due to no output from the other two LSS, resulting to the highest total hourly cost as well as incremental cost compared to the other two conditions. Hence, the generator 1 produce the same power. Full load with no output. This is the result. This one is the full load with various output from LS1, where we set here the LS1 to be 75 megawatt, while the LS2 is 40 megawatt. This is the full load with, this is the full output from LS1 only. Well, this one is the from LSS2 only. Next, we have come to the part of half load, where each of the load will reduce to 50%, so this is the new value for each load. As a result, here we can see all of the values decreases to the 50% load, and yet the conditions are still the same. We are going to observe the results for the half load condition. Basically, all of the values probably are deducted, also 50% from the previous full load. Allow me to show you that this is the half load with no output from LSS1 and LSS2. One is the various output, the same we set as the LSS1 to be 75 megawatt, while LSS2 to be 40 megawatt. This is the full output only from LSS1, that is 150 megawatt. Lastly, full output from LSS2 with 80 megawatt. As a conclusion to this part, generally the addition of transmission line doesn't affect the result, and it is just meant to control the overload.
Hi, my name is Terence Tujayong. So for my part, I'm going to do a simulation from part I to part T with condition loss of transmission line 4 with adding new transmission line. So this is the base circuit with loss of transmission line 4. You can see TL1, TL3 and TL5 is overload. So in order to overcome this situation, I add new 3 transmission line parallel to TL1 and add transmission line parallel to TL3 and add new transmission line parallel to TL5. So this is the circuit for the full load with no output from LSS1 and LSS2. So, and this generator 1 has 300 megawatt, generator 2 has 461 megawatt, and generator 3 is 357 megawatt, and the total hourly cost is 48,471 ringgit 50 cents per hour, and the incremental cost is 46 ringgit 36 cents per megawatt hour. So, and this one is for the full load condition with 4 condition, and this one is for half load with 4 condition. And okay, so the next one will be the full load with various output from LSS1 and LSS2. So the LSS1 will be 75 megawatt, and the LSS2 will be 40 megawatt. So you can see the generator 1 is still the same, and for the generator 2 is 397 megawatt, and generator 3 is 306 megawatt, and the total hourly cost is 43,459 ringgit 65 cents per hour, and for the incremental cost is 40 ringgit 81 cents per megawatt hour. And this one is the full load with full output from LSS1 only. Okay, so the full load, this one, the generator 1 is still the same. The generator 2 is 377 megawatt, and generator 3 is 291 megawatt, and the total hourly cost is 42,061 ringgit per hour, and the incremental cost is 39 ringgit 12 cents per hour. And for the full output from LS2 only, the generator 1 is 300 megawatt, still the same. The generator 2 is 416 megawatt, and the generator 3 is 322 megawatt. The total hourly cost is 44,917 ringgit 43 cents per hour, and the incremental cost is 42 ringgit 50 cents per megawatt hour. As you can see, the total hourly cost and incremental cost is the most highest when no output from LSS1 and LSS2, and for the rest, when the LSS1 and LSS2 is involved, the cost for both is reduced compared to no output from LSS1 and LSS2. This is because LSS1 and LSS2 act as the generator, which is solar energy, to help act as the generator which will reduce the cost. So for the next one is half load. No output from LS1 and LS2. The generator 1 is 174 megawatt and generator 2 is 218 megawatt and generator 3 is 167 megawatt, and the total hourly cost is 28,929 cents, 29 ringgit 52 cents, with incremental cost 25 ringgit 44 cents megawatt per hour. And also it was the same with the various output for LS1 and LS2, and still the generator 1 and generator 2 and generator 3 will be reduced when involved LS1. You can see the higher price no output from LS1 and LS2 in half load is 28,929.52 cents, and the incremental is 25 ringgit 44 cents. So for the other, the cost is more reduced compared to no output from LS1 and LS2. So and also if you look and overall, the result in half load is much more lower than the full load. This is because less power is need to provide. So the total hourly cost and the incremental cost in half load will be lower than full load compared to full load. And so we also can conclude that adding transmission line will not affect the result, only control the overload. And that's all for my part.
In conclusion, from the simulation, the overall cost is reduced when there is large-scale solar is involved, because it also acts as generator supply power, which reduces the other generator value. A full load system has a greater overall cost than a 50% load system, and the system generator output is based on the load demand theoretically. As the total load reduces, the generator output decreases as well, lowering the overall cost of the system. Furthermore, we show two strategies for resolving the transmission line violation. The first method is to add a generator to the network's bus 5, and the second method is to connect the overloaded line to a parallel transmission line. As can be seen from the results, the incremental cost of economic dispatch by adding generator, which is 10 ringgit and 75 per megawatt hour for the half load, when the full load output from LSS1 only is the lowest compared to the method by adding transmission line, when the full load with no output from LSS1 and LSS2, that is 46.36 ringgit per megawatt hour, which is the highest. That's all from us. Thank you.